All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So for the factoring, you should have x minus 4 times x minus 12. For the math knowledge question, this is just using our remote interior angles, our exterior angles theorem. So x and 45 are our remote interior angles, and they always have to add up to your exterior angle. So that means that x has to be 40 degrees. Okay, so we're looking at lesson 33 today, the converse of the Pythagorean theorem. So hopefully you'll understand how the converse of the Pythagorean theorem works after this lesson. So we're going to use Pythagorean theorem to review to find the length of x in each of these pictures. So on the first one, both of the legs are 10 because they are both congruent to each other. So 10 squared plus 10 squared equals x squared. So 10 squared is 100 plus 100 equals x squared. So that means that we have 200 equals x squared. And then you take the square root. And this is 10 and 20, which is 4 and 5, and 2 and 2. And then 10 is 2 and 5. So 200 is 2 times 2 times 2 times 5 times 5. We've got 3 2's and then 2 5's. So we can pull out a pair of 5's and a pair of 2's. So that's 10, and then a 2 is left inside of the radical. So that would be your x value for A. For B, we're going to do square root of 20 squared plus square root of 5 squared equals x squared. After that, square root of 20 squared is just going to be 20. Square root of 5 squared is going to be 5. And then x squared. So 25 equals x squared. So when you take the square root, you get x equals 5. So that would be your answer for that one. Okay, so now we're going to look at theorem 33.1, the converse of the Pythagorean theorem. If the sum of the squares of the two shorter sides of a triangle is equal to the square of the longest side of the triangle, then the triangle is a right angle. So we know Pythagorean theorem says a squared plus b squared equals c squared. This is saying, we know that we can use that on a right triangle. This is saying if the two legs, if a squared plus b squared does equal c squared, then that means that you do have a right triangle. So it's basically going backwards from the original Pythagorean theorem. So we have a triangle with side lengths 13, 20, and 24, and we want to determine if it is a right triangle. So all you're going to do is set the two smaller numbers equal to the bigger number squared. And you put a little question mark over the equal sign. And you want to try and figure out, are they the same? If they are, then it's a right triangle. And if they're not, then it's not a right triangle. So 13 squared is 169. 20 squared is 400. And then 24 squared is 576. And so over here I get 569. Does that equal 576? No. So it is not a right triangle. That's all you have to do for the converse of the Pythagorean theorem. Okay? So now we're going to determine if either of these are a right triangle. So we're just going to do 8 squared plus 11 squared. Does that equal the square root of 185 squared? So 8 squared is 64, and 11 squared is 121. And the square root of 185 squared is 185. So 64 plus 121 equals 185. So does 185 equal 185? Yes. So that is a right triangle. Now, on this one, 11 is the bigger side, so we're going to say 8 squared plus 7 squared equals 11 squared. So 64 plus 49 equals 121. Do these work? 64 plus 49 is 113. Does that equal 121? No. So that's all you have to do to use your converse of the Pythagorean theorem. Okay? And some of y'all may be saying, based on the pictures, they were obviously a right triangle or not a right triangle. They don't always give you the picture, and sometimes they do, and it's misleading. So still need to work it out, even if it looks like it's a right angle or it doesn't, just to make sure. So for theorem 33.2, the Pythagorean inequality theorem, in your triangle, if you have A and B as the lengths of your shorter sides and C is the longest side, if C squared is bigger than A squared plus B squared, then it's obtuse. And if C squared is smaller than A squared plus B squared, then it's acute. So here's what I try to do with my hands. We have that side and we have this side. And this is if it's a right triangle. However, if we take this one and we turn it this way, what happened to our C? It got bigger, and so C squared is going to get bigger. And that means that this angle, if you look, is now obtuse. So if your C gets bigger, it's going to be a bigger angle. And then likewise, if your C shrinks, this angle is going to shrink, and so you're going to have an acute triangle. And so I use my hands and I look and I just move them closer or further apart, make like an alligator mouth, to help me remember whether it's going to be obtuse or acute. So we want to use the given information to determine if they're acute, right, or obtuse. So the biggest one is 8. So 4 squared plus 6 squared. How does that relate to 8 squared? We know they're probably not going to be equal, although they could be. 16 squared plus 36, and then 64. So 16 squared, or 16 plus 36 is going to equal 52, and that is less than 64. So the hypotenuse is the biggest one. So that means that it's going to be an obtuse triangle. This one is the biggest. Okay? So now looking at this one, we have 11 squared plus 14 squared. How does that relate to 15 squared? Well, 11 squared is 121. 14 squared is 196. And 225 is 15 squared. So if you add 121 plus 196, you get 317, which is bigger than 225. So our hypotenuse is smaller. So that means that we have an acute angle. So we have an acute triangle. Okay? So that's how you can use your inequality theorem on your triangles. We're going to look at one more practice problem. We have a ramp that is being built, and they want to make the slope 2 to 5. And we need 25 feet of clearance. How far are we going to be away from the highway, and what is the length of the ramp? So the first thing you have to do is figure out your x value, and you're going to use the slope, the rise over run. They tell you is 2 over 5. So the rise part is a 25 here. That's how much we're going to have to go up. And we don't know how far we're going to have to run for our x value. So if you cross multiply, 2x equals 125. And then 125 divided by 2 is 62.5. And the units are feet. So that would be your x value. And then once you have your x value, you can use Pythagorean theorem to find your y value. So 62.5 squared plus 25 squared equals y squared. So 3,906.25 plus 625 equals y squared. So if you add those together, you get 4,531.25. And then you take the square root of both sides. And y would equal 67.3 feet. So that one was really just using Pythagorean theorem. You're not using the converse of the Pythagorean theorem or the inequality. That's just another practice problem on Pythagorean theorem. All right, so we're going to look at some practice problems now. So y'all pause the video and try these two, and then we'll go over them. So we're going to use Pythagorean theorem to solve for A, and it says put your answer in simplified radical form. So that's 400 and 729. And if you subtract, you get 329. So you take the square root of both sides. And 329 does not factor. It's prime. So that'll be your answer. For this next one, we want to figure out if it's a right triangle. So do these two sides equal? So 8 squared is 64. 14 squared is 196. And does that equal 225? So if you add those together, you get 260. Does that equal 225? No. So it's not a right triangle. Okay. Now we're going to look at these. Determine if they are obtuse, acute, or right. So y'all pause the video and try these real quick. So this first one, looking at the picture, it looks like it's going to be obtuse. But we still need to check and make sure. So 7 squared is 49. 8 squared is 64. And 13 squared is 169. And 49 plus 64 is 113. Does that equal 169? No. This one is bigger, so it is obtuse, just like we thought it was based on the picture. Okay, looking at this next one, you may think it's a right triangle, or you may think it's acute. It doesn't look obtuse to me, but we'll see. 7 squared plus 24 squared, how does that relate to 25 squared? So 49 plus 576, and then 625. And if you add those together, 625 equals 625. So it is a right triangle here. So that's how that works. Okay, so let's look at one more practice problem. See if y'all can try this one by yourself, and then we'll go over it. It tells us we have a ladder that is 6 feet above the ground. The ladder is 10 feet long, and then it says that this part here is 7.5. And it wants to know, is this right here a right angle? So we're going to do 6 squared plus 7.5 squared. Does that equal 10 squared? So 6 squared is 36, and 7.5 squared is 56.25. Does that equal 100? So if you add those up, you get 92.25, which is not the same thing as 100. So it's not a right triangle. And the reason, this is an obtuse triangle, because 6 squared plus 7.5 squared is less than 10 squared. So that's your reasoning. Your hypotenuse squared is bigger than the other two added together. Okay, so now let's look at this challenge question. is a parallelogram or rectangle if it has side lengths that are 16, 16, 20, and 20, and a diagonal that is 24 centimeters long? How do you know? So y'all try this one, and then I'll go over it. So we have a rectangle, or we have what we think might be a rectangle, and the diagonal is 24, and we have side lengths 16, 16, 20, and 20. So we need to use Pythagorean theorem. So 16 squared plus 20 squared, how does that relate to 24 squared? So 16 squared is 256 plus 400, and then does that equal 576? This is actually not 576. It adds up to 656. So is this a rectangle? No. And how do we know? We don't have a right triangle. So we don't have a right angle. And so it can't be a right triangle. It can't be a rectangle since we don't have a right angle there. All right, so hopefully that helps you a little bit with lesson 33. Your homework tonight is 1 through 30, so make sure that y'all do those so we can go over your questions tomorrow.